Okay, so for the second talk, I'll try to keep it short. This is a crammed down version of an hour-long talk in a half hour, so hopefully we'll keep it to that. But we're going to be talking about Famous today. Before I get started, who has heard about the Famous web framework? Show of hands. About 7 or 8 of you. Of those that have heard of it, who's downloaded the starter kit and played with it? A couple of you? And who got stuck after about 10 minutes and kind of gave up? Okay, so before we go in and talk about Famous, just a quick 2 seconds about myself. I'm the CTO of a company called Voxa. We're based in Buckhead. We are an email intelligence platform for sales teams. We do cool stuff like provide email response analytics and alerting about who you should follow up with when. A lot of this is geared towards sales teams. Before that, I was in grad school at the University of Maryland, so spent some time in the Northeast, and then I was out in the West Coast for about 6.5 years, and moved back about a year ago, so it's good to be back in the Southeast. This is kind of home for me, so it's nice to be back. So before kind of going into what Famous is, I want to just sort of set the stage why I think we should all care about Famous, or the types of things that the folks at Famous are trying to do. And for me, it's a pretty simple answer, which is I want to build cool stuff. And I'm a web guy. I've been building web apps, real-time web apps for the past 10 or 15 years in that time range. So for me, that's using tools like JavaScript and HTML and CSS. I just want to build cool stuff. So really, for me, then the question is, well, what do I think cool stuff is? And I'm really approaching, at least for tonight's talk, from the context of building more advanced user interfaces from a UI and UX perspective. So this is a video of the Facebook Paper app. This is a native mobile app. I imagine most of you have seen it. Forget about whether or not the app itself and like the things they're trying to do are cool, but just from a UI UX standpoint, I think this is actually, they did a really fantastic job. Just the transitions and the animations and how smooth it is, I think it's really, really freaking cool. So that's the kind of thing I'd like to build. If I go out of kind of mobile land and just think about from a web app perspective, this is an app a group put together for the World Cup, which I happen to kind of put into this cool stuff category. So they have this really cool 3D kind of soccer ball that flies in, and you can kind of drill around in here and make use of three-dimensional space for just browsing teams that were in the World Cup and filtering them out. So this is the kind of stuff that I want to build, that I want my teams to build. And kind of gets me excited about being a web developer. Like, how can I use our stack to build stuff like this? And the reality is that, for the most part, this is actually hard as hell to do, this type of cool stuff. And most of us may have these aspirations saying, yeah, I'm going to build this cool app, and I've got all these great ideas, but when I come trying to implement it, you just hit massive roadblocks, and you start just screaming, like, why the hell is this so effing hard? And you kind of give up, and you go back to just Bootstrap or something else, and you move on with life. So the reason why Famous is interesting for me is because it's starting to make this type of cool stuff easier to do. And if it's not Famous, it can be something else, and we can talk about what some of those other options are. But the problems that they're trying to solve are kind of twofold. If you are a web developer and you've tried to do stuff like this, you'll hit roadblocks, especially when you're starting to target platforms like mobile, where the app is just sluggish. The rendering algorithms for the mobile browsers, or even on desktop too, it's just not going fast enough. And what compounds this is then you have really, really jittery animations. So you want the experience or your rendering engines to go faster and smoother, so you're not jittery like there's Farley here. And so historically, what your options have been kind of roll your own and be very, very careful about what you do inside of your app and how you implement animations and transitions. And in particular, the biggest roadblocks that you will eventually hit are that the rendering algorithms or layout algorithms that the browsers employ to figure out where to put what on the screen just slow down if you do certain kind of no-nos. So what you have to end up doing is trying to keep your DOM really lean. You have to make as much use of the GPU as possible by doing things like CSS 3D transforms. And yeah, I was in grad school a long time ago, but I hate matrix math. This isn't my thing. You have to like avoid really deeply nested CSS selectors. So what this really turns into, if you're just trying to do it on your own, is you're just stuck in this pit of hell, and you go back to Bootstrap. It's typically what people do. So with all of this, this is kind of what motivated the folks at Famous to actually build this framework. So they initially set out to build just a cross-device app that was just going to be implemented using a web stack. And they raised a bunch of money, and they realized they couldn't do it using just JavaScript, HTML, and CSS3. So they said, hey, you know what? Maybe we can solve this broader problem of just making it easier to do this cross-device stuff using our web stack and making it really interactive and 3D and crazy cool stuff like that. So they launched in August of 2012, I think, something like that, at TechCrunch Disrupt with this demo. And if you were like me and you were kind of an avid web developer at the time, and you saw this, you were like, holy shit, this is awesome. Like, what are these guys doing? This must be some janky Flash plugin or app there that they're using or something else. And what really shocked people was that when you go in and inspect Element, what you're going to find is that this is just DOM. So they've built, at the time, this demo that has this new take on the periodic table that we all learned in high school in 3D space running in a browser using just straight DOM. And what got people even more excited was that this was cross-device, running at 60 frames a second, and they claimed would be released as open source. So if you were like me, you got pretty excited about this framework, and this was in 2012, and then a year went by, and you're like, when are these guys going to get their stuff together and launch it? And then another, I guess, not quite a year went by, and they finally released something in April of this year. So so that's kind of a little bit about what they're trying to do at Famous, is to solve this problem, make things go faster, make them more interactive and smooth from an animation standpoint across different devices, using things like just straight DOM, so just traditional web tech that we're all kind of familiar with. So what I want to do now is kind of go into a little bit of underneath the hoods about what exactly they've built, and we'll look at some very kind of foundational examples that should kind of give you an idea of how the framework actually works. So the biggest problem that they've tried to solve is really the fact that most modern web browsers just don't do that great of a job when it comes to performance of figuring out where to position things on the screen. So the layout engines are trying to crunch CSS directives about absolute positioning and top left, and then doing this across deep DOM trees just breaks down when you're trying to do things at 60 frames a second in this really kind of smooth, interactive environment. So what they've done is said, forget about DOM. We're going to abstract away DOM, and we're going to basically reduce everything to matrix 3D transformations. As I mentioned earlier, the great thing about that is that just gets piped into the GPU, and the GPU figures out how to kind of paint the screen or paint the scene. So what they have built is basically a JavaScript API that allows you to manage a scene in such a way using their APIs that you don't really mess with DOM. So if you're a jQuery person, you've got to really forget about doing DOM selectors and adding or removing things from DOM. You're just going to use Famous's API to manipulate your scenes, which is a foreign concept. It was foreign to me, and still is foreign to me, but that's just their solution for now. So that kind of solves the go faster problem. The next thing they wanted to do was make the kind of the animations and the transitions in 3D space that they could build feel much more natural. And if you go into the gaming space, the way people solve this problem is really by using physics simulations to get more natural effects. So they coupled very tightly with their kind of 3D layout engine, which we were just talking about, a 3D physics engine. So that allows you to do physics-based animations and transitions that give you a much more natural feeling effect. And this is, again, people in the gaming industry have been doing this for a very, very long time. This is not new, but they're kind of one of the first ones to do it in a JavaScript land that actually integrates with the layout engine. So those are kind of at the high level the two kind of core contributions that these guys have done so far. So next, let's talk about okay, at a high level that's what it does, but what really happens, how to use this stuff. So let's talk about some fundamentals. So I said this before. Forget about DOM. So you're not going to be manipulating your DOM tree directly. Underneath the hoods, Famous will actually be changing the DOM, but you're just not going to touch it. So that's just the first concept, again, that you really have to get your head across. So instead of DOM, what you have in the Famous land is what they call a rendered tree. So every tree has a root, In the famous parlance or scheme, that's what they call a context. So this is kind of like your body in DOM land. So once you set up your kind of web app and you kind of import their JavaScript libraries, you're going to get a handle on this little engine object, and you can create a context, which basically in an abstract sense creates this root of your render tree. We're just going to note this on your right-hand side. I'm sorry, your left-hand side. Yes. Okay, so once you have your root of your tree, what do you want to do with it? Well, most of the time when we're building a web app, you're going to add some content to it. So you may have some text or some images, a video, whatever. So in famous parlance, you have this kind of core component which is called a surface. So surfaces are for rendering the static type of content. Think text, think images into your scene, into the web page itself. So the way you would do this, and we'll go into a couple simple examples in a few minutes, but you would instantiate your context, you instantiate your surface, and then you simply on your context do a .add, and you could add your image or whatever to the actual scene. So underneath the hoods, what you'll see is what Famous will do is it'll create a div for your context, then it'll create a wrapper div for your surface, and then inject that sucker into the DOM for you. But again, they're managing it, you're just using their API. So life would be pretty boring if we could just render static content to the screen. We probably want to move it around. I mean, we're talking about doing, interactive, high fidelity kind of 3D kind of app and experiences. So to do that, you have this core component called modifiers. So think about these as like CSS animations or transitions, that type of stuff, or positioning. So what you can do is you can instantiate a modifier, and then you can apply that modifier to your surface. So this is we're kind of arriving at a very important concept about how the famous rendering algorithm works. So when on basically their engine, the rendering engine, what will happen is at a frame rate of 60 frames a second, it will come in and evaluate where things should be positioned on the screen. And it will actually inspect this thing from top down. So every modifier in your render tree, the effects of that modifier are going to actually be applied to all of the children in your render tree. So let's take, for example, that this was an image, and I said that I want to rotate that image 45 degrees about the y-axis. I could specify that kind of transformation using a modifier, and then if I had other images kind of anchored off of this, it would be applied to not only that one image we have there, but other ones that I could inject into the render tree as well. So it reads from top to bottom. If I say rotate 45 degrees here, it's going to go to all of its children. Similar to kind of DOM, where you have like relative positioning, where you're positioned relative to its parent. Last kind of abstract thing before we look at some actual code, real code, is that most trees have branches, and this is kind of following up on what I was just mentioning a second ago. Let's say, for example, we had this first modifier that rotates everything by 45 degrees about the y-axis. Let's say I had a second image that I also wanted to maybe move by 200 pixels down on the screen, so about the y-axis. I could basically, create a fork off of this first modifier where I'd add that image, initial image that we rotated 45 degrees. I could then add a second modifier that's anchored on this first modifier that says also move it. And then that would be applied to its children. So you're going to have like a rotation at 45 degrees, then move by, call it 200 pixels. So this would be affected by both of those modifiers. So it's kind of the way you can build up complex movements and animations using these render trees. So that's a bit in abstract. So what I want to do now is let's quickly look at some basic examples about how you would actually apply this in its kind of simplest form. So let's start with this super cool example of taking a simple 200 pixel by 200 pixel square and centering it on the page. So I'm going to go over to some code. If you go and download the starter kit from the Famous website, they have a basic setup that you can use like this. There's more complex ones where you can use like a Yeoman generator to get more elaborate kind of application structures. In its most basic form, you're going to have something like this where you're going to import in basically the Famous libraries. Then you can import your CSS and just your main JavaScript function. So this should be really basic, I think, for everybody. So the real meat of what we're going to do is in this main.js file. Okay, so what we said we want to do, we want to create just a square div centered on the screen. That div should be 200 pixels by 200 pixels. So what we're going to do is we have a handle on this global kind of Famous object where I can get a pointer to the engine, to the modifier, and to the surface. So two classes we sort of talked about. I'm going to refer to these as classes. So the first thing we're going to do is come in here and create our context, which we kind of did in the earlier examples. We can forget about the perspective here, that'll come up later. So the next thing we're going to do is, again, we want to create a square. This is going to be static content, so we're going to use a surface. What Famous actually happens to do with surfaces, these just kind of result in divs that are going to be injected into the DOM. So when I create a new surface, I can pass in some options here. And there's two kind of base options that we're going to make use of. One is the size. This is just an X and Y, so width and height. And it's going to be in units of pixels. Next, you can have an arbitrary array of CSS classes. So this will make use of some CSS styling I have separated out in my CSS file. You could optionally put in a properties hash and just inline the actual CSS directives. I typically don't do that, but you could do that here as well. So that would give us our square. The next thing we want to do is then center it. So we've got our square, but we want to actually put it in a correct position. So we're going to use a modifier to do that, like we talked about. That deals with all kind of positioning of elements in the Famous land. So when we create our modifier, it's going to also take in an options hash. There's kind of two core things that you will always use in a modifier, which are going to be your alignment and your origin. So you can think about alignment is sort of your vertical and horizontal positioning of whatever objects are below it. So this starts, it's an X and Y coordinate space. Top left is going to be 0, 0, 1, 1 is going to be bottom right. So 0.5, 0.5 is going to be center. The next thing, which is origin, is actually relative to the thing, the surfaces below it. So this basically says, what do I want to treat as the center point for the object that I'm moving around? So again, this is in a 0 to 1 XY coordinate space. So top left is going to be 0, 0, which would be the top left corner of my square. 1, 1 is going to be bottom right. 0, 0 is going to be in the center. So we're basically saying, align the thing in the center, and we're going to treat, the center of the square as the origin point for the square itself, which will actually make it centered. We'll move these values around just a second to kind of show you how that works. So then once you do that, we've got our modifier created, we've got our square created. We're going to add our modifier to the render tree, and then I can kind of daisy chain these things together just to build up a tree structure, and that's going to render our square. So let's come over and drag this guy into Chrome, and magically we have a centered square here. And just to illustrate some of these things, if I were to change the origin to 0, 0, what's going to happen is the center point is going to come up to here. So let's save this or refresh. So it's now, centering based on the new origin of the square, which is top left. So it's in the center of the screen. If I were to change the alignment to 0, 0, you're going to get a square in the top left because we've basically moved basically said align the square relative to this viewport at the top left corner. Does that make sense? Okay. So if you're like me and you saw this, I'd say, geez, that's a lot of code just to create a square and center it. I could do that very, very simply with just some HTML and CSS, which is true. However, when we start to get into some more elaborate kind of transitions, you'll realize where the payoff comes. So let's go back to our slide. Any questions so far? Everyone good? All right, cool. Okay. So we've basically used a modifier to dictate, sort of positioning using just the alignment and the origin. What you can also do is use a transform attribute. What this will actually take in is a 3D matrix. Famous will crunch that and then figure out how to use that for doing things like moving the objects below it, rotating them, scaling them, so on and so forth. So if we wanted to take our square, move it down by 100 pixels, to the right along the x-axis by 100 pixels and down by 200 pixels, you could use this transform.translate function that will return a 3D matrix that will take into account that movement, that translation, and then hook it up to the transformed object on the modifier itself. So if I were to do something like that, what's going to happen is my square is just going to move down. So let's go back to our examples and do that. And again, we're going to incrementally build this up into something more interesting. So here on our second one, really not much has changed. If we kind of look at the difference here, all we've done is imported in the transform class. Then we're going to set the transform attribute. I'm just kind of toggling between the initial example and this example. Then I'm setting the transform attribute on the modifier. So if I come in and refresh this guy, or sorry, load this guy, you're going to see it's going to move. So just to illustrate how this works, we can monkey with these values, and it's just going to move things around. So if you look underneath the hoods at what's actually happening here, notice that all the positioning is happening using these matrix 3D transforms. So Famous's rendering engine is figuring out how that should be adjusted. That all gets hardware accelerated or rendered by the GPU, and that's where they're getting the performance. You start doing this stuff with some animations. Okay, everyone still with me? All right, I see head nods. That's good. All right, so let's do something a little more fun with transforms. So the interesting thing about the Famous rendering engine, again, it runs at a kind of an animation loop of 60 frames a second. So at a rate of 60 times a second, it's going to reposition elements on the screen. So the way it's going to do that, it's going to basically inspect the modifiers and look at their transform attributes. If they can either be kind of a static kind of 3D matrices that we were using before, or you can have a function that will return a different value that can change over time. So let's say we had that square and we wanted to start rotating it about the y-axis. Well, we could do that by changing our transform to be a function that returns a different matrix over time. So we could have a kind of an externally hard-coded angle, just bump this angle on every tick of the rendering engine, and then use that for the rotation. So what's going to happen is that angle is going to be slowly increasing, and it's just going to effectively move adjust the rotation for that, for all the elements below it, given your kind of the amount you're actually bumping the angle. So if we were to do something like that in our example, we're going to get a rotating square about the y-axis. So let's go do that one, just to show how that works. Okay, so what we did, not much different here. We basically, I'll come back to this in a second. Sorry. So we have our angle, we have our modifier, our transform is now a function that returns this, kind of updated rotation. An important thing to note here is that in Famous Land, I don't necessarily like it all that much, but it just comes down to the mathematics underneath the hood. All the rotations are in radians. So that goes back to the unit circle and trigonometry. There's a simple conversion to convert it into degrees, and you'll see that later. But this rotation, this angle is in radians, just so you guys know. So what we're basically saying is, bump the angle by 0.03 radians and then set that for the rotation. So if we come over here and drag in this guy, we have a big bug. I guess it doesn't like this. So there's our square kind of rotating. So by default, any DOM element, its back face will not show the front face. It won't be initially visible. So there's a little workaround to effectively make this thing see-through in some sense, so that the color will show on both the front and the back of this DOM element. Which is the thing I removed earlier, which is this backface visibility command or CSS directive. It just sets this guy here. So that's just a simple way to have the front back share the same kind of UI kind of value, if you will. So now we have this rotating square here. What we can do if we wanted is make it rotate a lot faster. Over here, refresh. So this is just yeah, question. Go ahead.
So what determines the frame rate?
Their engine just assumes 60 frames a second. So
they'll ensure that happens?
No. So you can write bad code and you will not achieve 60 frames a second. Absolutely. So that is a gotcha. This is not something specific to Famous. If you look at any gaming engine, so say you're using Unity or any of the more typical mobile gaming frameworks, there's always inspectors that will output what frame rate you're getting based on how complex your scene is. So for most, basically all the demos they have running on their site, they're going to achieve nearly 60 frames a second. Any other questions?
And they will just call this transform function as fast as they can, I guess?
Yeah, well, I mean, the engine is going to be ticking, at a rate of 60 times a second, they're going to invoke it. Now, whether or not, You know, the JavaScript engine, if V8 is going to keep up with that, that's a different story.
And so if you have a lot of modifiers, this could be potentially doing that.
Yeah, it actually comes down to how many surfaces you typically have on the scene, not the modifiers. Because the modifiers, they don't result in more DOM elements. So where they've seen, you know, when things start to get, you know, weighted down is when you have like thousands of surfaces on the screen and you're moving them all around at that frame rate.
It just gets all choppy at that point?
Yeah, it's just going to get, remember that jittery stuff? You're going to get stuck in that one again. Yeah. Some stuff I'll show you later is they're starting to work on mixing DOM and WebGL, in which case this is kind of a non-issue. Did you have a question?
What browsers does this, or what browsers are
Yeah,
supported?
so basically everything except for IE.
What?
Yeah, shocker. The problem is just IE's got to catch up with some of the 3D pictures.
Yeah.
Yeah. They're working on it. You know, look, for me personally at Boxa, I'd love to be pushing famous stuff out into production. We're a B2B app, so we have this requirement of servicing clients using IE, which, you know, the web development purist in me says, oh, forget about them, but the realities are that's not always that easy. You know. Okay, so let's keep going here. Just gonna kill this. All right. So if you think about what we're kind of doing with that angle value that we were just kind of globally bumping, is we're sort of maintaining some state in some sense. There's other ways to do that in Famous. You could use, they have this Transitionables class, which you can give it basically a duration and an easing function, and it'll transition some number between 0 and 1 over that. So then you could use that for like certain type of UI effects, you know, where something kind of comes in with some bouncy or, you know, some curve. If you're kind of familiar with jQuery easing curves. They also have a different type of modifier called state modifier. What you can do with the state modifier is, you know, given your transforms that we were kind of playing with, you can also pass in other attributes like a duration and an easing curve, and it will perform that transformation over that duration using that easing curve. So again, if you're familiar with jQuery easing, then this is going to sound pretty familiar with you. The other kind of cool thing about this is that you can stack these things up and they'll just execute one after the next. So if I did something like this, I'm going to first rotate by 1,000 radians on the y-axis over 500 milliseconds. Once that's done, I'm going to go and rotate back to the origin point, which is at 0 radians. So if we did something like that, we're going to get an effect like this. So we're just rotating 1,000 radians along the y-axis. So it's like a 45-degree rotation. And that'll happen over a duration of, what was our duration, 500 milliseconds using the ease out bounce easing curve they have. And then once that's done, it's going to rotate back to the origin, which is 0. So let's go and do that in the code. We can change a couple of values so you guys can see how that works. So instead of just a regular modifier, we're going to kind of require in or import in this state modifier. We build up the modifier just like we did before. Instead of passing the transform in as an attribute of the options hash here, we're going to use this set transform method that the state modifier exposes. Then what we can do is a little bit more visible. So what we're telling this to do is say set the transform to whatever this 3D matrix is. So this is going to basically say rotate along the y-axis 1,000 radians, call it 45 degrees. Do it over 500 milliseconds using this easing curve. Again, they have a lot of the same easing curves that you get with like jQuery. Then it says after that, rotate back to 0, this is where we started, and do that over 3 seconds using this same easing curve. So if we come over, and let me just make sure it's saved, drag this guy in, there's our effect. So we're going to rotate back by 1,000 radians over half a second, and more slowly rotate back to the origin. And again, we could change these values here. You guys still hear me? Did I cut out?
Yeah.
Check. Yeah, it's fine like this. Okay, better? Let me know if I end up yelling at you. So what we could do if we wanted to is, change these durations. just to show you how these things are going to work live. It's just going to go a lot slower. You can change the different curves. I don't have any of them offhand, but you can kind of fiddle with all these values here. Any questions? Everyone good? Great. Okay, so as I mentioned before, Famous provides this physics engine as well. So you can do cool stuff like set up colliders and particles and have gravitational forces and do all kind of fancy things. They also give you some sort of easier to use hooks to make use of that stuff for things like animations and transitions. So one of these, we'll just give a quick example, is using basically a spring transition, which is going to just have a springing effect that will be simulated using the physics engine, in which where you have some oscillation and damping to kind of dictate this springy or bouncy effect. So in this case, you could just, this is using require.js, pardon, there's a little bit of break from what we're doing in code, but you get a handle on the spring transition class, and then you can just pass in some different parameters, including the period and the damping ratio, which are just configurations into the physics engine that will execute that, that particular transition. So if we go back to our examples and see what we have here, we're using this spring transition to dictate how the object is going to be transitioned about the y-axis and then back. So you're seeing this more natural, kind of fluid UI effect, if you will. So let's go to code and play around with that some. Again, fairly straightforward, small incremental extensions of what we had. So we're now importing in the spring transition class, and we have our state modifier still. We're just going to do the same transformation here about the y-axis, this rotation, and we're going to use a spring transition, and then this period of 1500 milliseconds, so 1.5 seconds using this damping ratio. Once that's done, we're going to go and then rotate it back to the origin point of 0. Again, same transition, just a different period. So you're going to basically see a prolonged swing back, and it's going to snap back in just more quickly. So if we come over to our physics example, and this will come back. So we can kind of fiddle with these values if we want. Let's maybe bump this to 500. Let's see what we get here. So this gets kind of cool when you start to fiddle with the values here, so you can kind of adjust the dampening. And that's just basically the resistance of the oscillation. So this guy is just going to flip back and forth. So the cool thing about the physics engine is you can really tune the UI effects however you want. So if you have a button or some animation or some image and you want to bounce and have some really custom effect, you can do this much more easily using their kind of out-of-the-box physics-based transitions. Make sense? Okay. So let's go back to our slide deck here. So these are so far, kind of very simple, just single surfaces and modifiers to do, kind of individual effects. Is that working good? Okay, you guys hear me? Check, check, check. Perfect, great. Okay, so they also provide this notion of views. You can think this as just a logical encapsulation of a collection of modifiers and surfaces. So you want to build up widgets or components that you can inject into the render tree. So out of the box, Famous has things like scroll views. So think about like your Twitter news feed. They give you that kind of widget, if you will. Header footer layout. So if you're building just a typical app with a header, content area, and a footer, you can use their header footer layout. They'll deal with a lot of that positioning and automatically, resizing everything. Grid layout, so on and so forth. You can also roll your own, so you can actually extend the view class. You can make your own views. So if you want to build your own little widgets or componentry, you can do that yourself. So what I thought we'd do last here, just our kind of examples before we look at some real eye candy, is take our square, turn it into a 3D rotating cube, basically using some of the stuff we've been doing previously. So what we're going to do is go over to our code and look at our cube example. Okay. So the first thing that we've changed here, we've just imported in our view class. A view is in famous parlance, is a render node, meaning it's something you can add to the render tree. It's also things you can add other renderables to that will just show up in your render tree. So they basically offer me a .add method where I can add surfaces and modifiers to them. So what we're going to do is build up a cube class. We're just going to use basic JavaScript prototypal inheritance. So we're going to define our cube. We're going to basically call the view constructor. We're going to accept some options, which are just right now the size. So what's the width or height of the squares of the cube, of the faces? We're then going to call a method to init the surfaces, basically construct the cube. So we've also got, again, basic kind of, I'm going to overlook the JavaScript kind of class inheritance simulation stuff. So the real meat is in this init surfaces. So if you think about a cube, well, what is it? It's 6 square faces that are rotated and translated to construct this cube in 3D space. So if you're the right face, what do you have to do? Assuming you have just six squares stacked on one another. You've got to rotate it by 90 degrees and then translate it about the y-axis by half of whatever your width of the cube is. So for us, if we're going to do a 200 pixel by 200 pixel cube, we're going to do a 45 degree rotation, then translate it about the x-axis by 100 pixels. So the way we're going to kind of encode this here is we're going to have an array of rotations, one for each face. So this is in x, y, and z. And then we're going to have an array of translations. So we're basically just building up, an internal data structure that will basically represent transformations we're going to have to apply to each of the faces to construct the cube in 3D space. Here you can see, I, again, don't like working in radians because I don't speak the unit circle, so I'm going to convert these values. So if you look at this, this is the front face. The front face isn't rotated at all. So there's just no rotation applied to it. That's why you have 0, 0, 0. This is, I think it's the right face, so this is a 90 degree rotation about the y-axis. This is a negative 90 degree rotation about the y-axis. This is going to be the opposite face. 180 degree rotation, so this is going to be your back face, so on and so forth. Translations, again, we have this internal size notion, so we're going to pass it by default 200. So this is going to just construct where we want to move these faces. So the front face, we're going to move it up by 200 or by 100 pixels. Back face, we're going to move, where does that one go? So this is going along the z-axis. So here's the back face, so it's moving it back by 100 pixels. The right face, we're translating about the x-axis by half the size, so on and so forth. Does that make sense? Cool. So now what we're going to do is just loop through our this array of 6 here and collect some modifiers, add the surface, and then magic layer cube is going to be constructed in some sense. So in order to make this visible, I've made the cube, I've reduced the opacity, so you can just see the back, some of the other cube faces. So we're going to use 3 different modifiers here. Note you could absolutely combine this all into one modifier, but just for illustration purposes, we're going to have 3 here. So we're going to build up our opacity modifier that sets the opacity to 0.8. We're going to use the translate modifier, so we're going to create a modifier for the translation. It's just going to index into the array, do a little JavaScript magic to just apply the actual values to that particular method. Same thing for the rotation, using our surface rotations array. It's going to create a surface, then it's going to add it to the view. Again, the view is a render node, meaning I can just add things to it, and when I add the view to the render tree, it's going to include all those other things. So if you were to think about our abstract view of the render tree, we're going to have 6 branches, where each of these branches is going to have an opacity modifier, which is going to have a child, which is the translation modifier, which in turn is going to have a child rotation modifier, and we're going to have the surface. So we're just daisy chaining these things down. So it's like, change the opacity, translate it, rotate it. Here's what I'm actually applying everything to. Here's my little helper math to get out of nasty unit circle space. Then all I'm going to do is instantiate my cube with my size. And then eventually, down at the bottom, if I can move that guy up. Well, we wanted to actually rotate our cube, so we're going to go back to our previous example where you have this kind of hard-coded angle that we're just bumping over time. And I'm going to add the cube as a whole, but I'm going to add it as a child to this rotation modifier. So again, remember, everything's applied to all of its children. So this is where you can start to compose these more complex animations using this notion of the render tree and everything kind of following down the tree. So let's start without the transform. I'm going to comment this out and come and load this example. And then we're almost done. So here's our cube without it rotating. We come back in and uncomment this, we'll refresh. We're going to now see it starting to rotate.
Where did you sort out the perspective?
Yeah, so that's up top. So that's a typical 3D thing. That's just the notion of depth. So basically everywhere I've seen it, it's usually set to 1,000. How that actually impacts the underlying engine, I could not articulate that very intelligently at this point. What we could do, I mean, we kind of made this in a modular sense, in some sense, so I could set the size to 400. We're going to have a larger cube. You could also do this with scaling, so I could have a scale-based modifier to not have to actually hard code the size. We could say, right now we're just rotating over along the X and Y axis. I could come in and say, okay, let's also rotate it about the Z axis. Refresh that. It's just going to have a different effect. So if you think about, taking these primitives and packaging them together and then using that in a broader app, this is kind of the way you do it. Okay, so any questions on that? I know we're running late, but I'm happy to answer. Yeah.
So the units are pixels. What about high resolution displays?
Yeah, so you're still going to, it's still wetland, right? So you're going to have to deal with that in some sense. So if you're using imagery, you can do the typical CSS media queries to figure out which, versions of images you want to use, that kind of stuff. But, you still will get pixelated. If you zoom in on an image, it will eventually pixelate. It's not vector. Does that make sense?
Right, but so if I'm drawing something that is 200 pixels, this is going to the GPU and being pushed out, or it goes back through the...
At the end of the day, the GPU in this example is simply rendering a div. If we come in and look at this, these are just square divs with CSS stylings on them. So the GPU is just dealing with the positioning of the object on the screen. At the end of the day, it's just a div. So it's just null. So you could zoom in on this because of the, because it's just a div, it's not going to get pixelated. But when you deal with images, you zoom in on it, you're going to, that'll get pixelated. Yeah.
So I guess to this question too, if you add an image to that surface, it's going to slow it down because it's going pixels?
No, that would not slow it down. What's going to end up slowing you down is when you have thousands of these things going on. But the GPU will suck that stuff up. Any pixels, the GPU is going to, it will not be a problem. Okay?
But it's the calculating of the actual matrix values that jumps.
We'll start to slow down, yeah. Okay, so so far the examples of physics have been kind of pretty elementary. You have a full-blown physics engine. You can add particles and forces and colliders to it. So there's a lot of cool stuff you can do with that. They also have eventing, so they actually suggest that you use their event handling. So if you want to do like click handling on a surface, they kind of provide that for you. Famous is just the view layer in your MV whatever framework. So if you want to build a more robust web app, you're going to need things like routing and models and controllers, that kind of stuff. So you still will be using things like Backbone, Ember, Angular. They have very robust Angular binding and hooks already. They're working on Ember. Backbone's pretty simple just because of how bare bones Backbone is. This presentation is built in Famous and Backbone, so it's relatively simple to do. So far you may be saying, okay, cool, you can make a rotating square, but why the hell do I give a shit about this? So let's look at some things you can do once you kind of understand these core concepts. So if you've dug into some of the famous examples, you may have seen stuff like this, but you could imagine from a gaming landscape or gaming perspective, building out boards with tunnels and graphics like this. These are, again, this is all divs underneath the hoods. They're just scaling, rotating, all that stuff. And again, this will run on a mobile phone, tablet, all that cool stuff. Here's a slightly more robust example with our cubes. They just have more cubes spinning around in space that they're randomly moved. If we go back to our paper example, this video I showed you earlier is actually a port of the paper app into Famous. So this is running on an iPhone. This is all built in Famous. So you're able to deliver these types of UI effects. Obviously, the design, it's not easy to design things like this, but assuming you have a good UX designer and put these things together, you can actually build apps like this. Given that, you probably won't be surprised that, guess what? This example too was built using Famous. So they have taken sort of our notion of building a 3D square to the next level and have built this, whatever the forget the name of the shape of a soccer ball. But you know, this was all done with Famous as well. I mentioned mixed mode. So this is super, super cool. This stuff is bleeding edge. It's not even released yet. You have to literally be working in their office in San Francisco to get access to it right now. But what they're basically doing is coupling DOM and WebGL. So they're rendering to both DOM and WebGL in the same coordinate space. So what's cool about that, if you guys are all familiar with WebGL, is like fancy lighting and shading that you really don't see in DOM. You can actually start to achieve using WebGL. So they're starting to build things like this, and this will be coming out soon, and it's super, super cool. So all the letters here in the circles, that's all DOM. But the lighting that's coming off of the pressing, or when they press these keys, and this is tied to the actual keyboard when the developer's actually sitting there typing, that's all done with WebGL. So they're mapping, again, using the same API and framework, WebGL and DOM into the same coordinate space. So the lighting and shading is done with WebGL. So the types of things that you can start to dream up, with are really it's you're limited by your imagination to some extent. That and ID. But yeah, underneath the hoods, this is again they're just showing it's just DOM. The S is just the DOM element, so you're not having to write letters into Canvas using WebGL. So that's super cool. So wrapping up here, all things are not great, kind of sweet and easy. The framework is still very, very new. They're only on, I think, version 0.3, so new versions are going to break the API structure, so you will bleed on your feet some. There are some device quirks. Again, new framework. IE support, as we mentioned, quite frankly, is just non-existent right now, which is a big barrier for some people. You're not getting away from your more full-blown MVC frameworks, so you still need to learn. If you're looking for one framework to learn, it's not going to be just Famous. As a matter of fact, if you're looking to learn just one framework, I would say do not learn Famous, go learn Angular. But once you get familiar with Angular and you're looking at more elaborate UIs and interfaces, this is, I think, a really cool platform. There's startup risk. It is a startup. It's not backed by Google. However, they have a lot of funding and they have a pretty robust community right now. I think the user traction from developers is basically on par with where Angular was in its early days. Whether or not that is an indicator of the future, I don't know, but there is interest right now. Some of the resources, Famous University, this is kind of an interactive tutorials. You can kind of live code online, definitely worth checking out. You won't really miss it if you go to the website. They have a lot of courses you can take, which is really cool. The IRC channel, I'm assuming you guys are familiar with IRC, it's extremely active. We had an intern in last summer, basically said, his name was Darian, he said, Darian, go learn Famous and teach it to us. And he needed a lot of help. He was a GSU student. He did a fantastic job, but he got a lot of help on the IRC channel. So if you start playing with Famous and get stuck, and you email me and I don't respond to you, you can go to the IRC channel and get some help. Famous blog is very active. There's also a local Atlanta Famous Meetup, so I'd say come check us out. And that's all I got. I'd say, it may not necessarily be Famous in the future, but I think that the approach they're taking to try to build, higher fidelity 3D interactive web apps is a very, very interesting take on it that allows you to target more platforms using, the type of tech that we're familiar with. So it takes a little bit of getting used to, but if you're interested in this type of stuff, definitely check it out. I think it's super cool, and you can do some new stuff with it. So with that, talks online, you can just go to my GitHub account, this talks folder, and I'd be happy to answer any questions offline if you guys have any.